Welcome to Module 2 of Programming Logic using Python. I am Professor Fiske, and if you have liked my micro lectures up to this point, please like and subscribe. It would do wonders to let me know what content you're interested in, and if my content is for these specific subjects is too relevant. So, as I said in the other lecture, I like to use Geek for Geeks, Tutorials Point, Programmese, and W3 Schools. But more than any of that, I like to use the documentation that I find directly from the language writers. And in this case, I want to talk about the data types which matter the most in Python. Now, we're not going to talk about dictionaries or lists or sets or frozen sets or tuples at this point. Those are later on down the road. They are data types and we will use them, but the data types that are important to us are numerical, alphanumeric, and arrays. Now, what I would and at datetime too. So what I would say is the first data type I want to talk about are strings. So let's open up REPL, create REPL, and we're going to go to Python, and we're going to say this is lectures. Okay, PY lectures. All right, great. So we're in PY lectures. And let's go ahead and let's make some use cases. Let's do some things, shall we? So the first thing I want to do is I want to look at creating a string. Well, how do I do that? How do I create a string? Well, that's actually very easy. What I do is I don't write anything but what I want that variable to hold. So if I said first name, all right, equals, I can say what the first name equals. In this case, I can say John. If I wanted to print that, I would print the actual variable. Now, I'm not printing the variable, I'm printing the value that's assigned to the variable. So let's talk about what I just did here. On line 1, we have the variable name first name. Now you can name this whatever you want, you don't have to name it first name, you can name it anything, except for reserved words. So this print is a reserved word because it's used for a built-in function within Python, so I could never name this print. If I named it print, it would cry and say, you can't do that, that's a function name. So I would have to name it something important. Secondly, you notice that I did not capitalize any of the letters in this name. That's very important because capitalizing the letters in the name would be a taboo. It's a faux pas. You're not allowed to do that here. Not in a scripting language like Python. What we actually need to do is ensure that our actual names are case agnostic. Especially in scripting languages, your casing matters. So if you mess up the casing along the way down the road in your Python, you're in for a world of hurt if you did not remember that you did that. The last thing here is I named my variable a noun. And the reason why I did that is because it is very important that I let other developers know what this is without writing a comment. Now in my class, if you're taking my class and you're not just watching this on YouTube, you will write a comment in there so that you can give me the pseudocode after the fact. But in this case, I don't really like writing comments where they're not needed. This value, John, should be defined by the name of my variable. So in this case, the name of my variable is first name, which I'm declaring. I'm declaring the variable first name, and I'm asking the PC to hold a storage location in the random access memory so I can assign a value to it. And what I'm going to do is I'm going to assign an array of characters, otherwise known as a string. This is a string. Strings are printed. Now I'm using the word printed very loosely here. When you write a string, the string becomes what we call immutable. All right, so I'm gonna write a comment here. Strings are immutable. Immutability, or the idea of being immutable, is the opposite of the idea of being mutable. So if I said not mutable, so what does mutable mean? It means you can change, you can evolve, you can massage, you can define again. That's what mutability is. When something is immutable, that means that it cannot change. It is forever stuck that way. Now, within the case of this string, the string John is immutable. It cannot change once I make it. And this first name will not allow me to. If I wanted to change this string, then I would need to connect another string to it. I would need to modify the string by smashing another string into it. So let's say I had a string called last name. I'm doing this on purpose, by the way. If you want to define a string literal, which is what these are, you can either use single quotes or double quotes. All right, I did that on purpose. One or the other is fine. You can use them both too. I like symmetry, so I'm going to do single quotes because in all of my scripting languages, I like single quotes over double quotes. So now I have a variable called first name, which is storing the name John. I have a variable called last name storing the value or the string Smith. All right. This equal sign here does not mean that John equals first name. This equal sign here means that the value John is being assigned to the location which is named first name. The value Smith, the string value Smith, is being assigned to the variable location or the storage location in memory called last name. That's what this is doing. These two strings live in two different storage locations in my random access memory. Great. Well, if I print this, I still only get John. So how would I get Smith too? Well, that's easy. I can do something called string concatenation. So string concatenation means I can add two variables together. And look at what happens. I get John Smith. Now it's kind of smashed together. It's not very readable to the human. So in my opinion, what I would do is I would add a space after John so it's more readable, John Smith. And there you go. The space is a character in the string. Please understand that every character you can ever use in Python or any other language is defined by the ASCII2 library or the Latin library or whatever library that supports your language. In this case, we're using English. So the code runs from left to right, and the language which is supported, or the binary that which is supported, is ASCII2, which means that space is an ASCII2 variable or an ASCII2 symbol, and that's strings. If we go a little further, we can actually remove all of this and give John an age. We'll say John's 45. Now, at this point, what I want to do is I want to start modifying this string and giving it other things. Now, please understand that this is a string, right? The first name is a string, and you can see it, literal John. It's a literal string. This is a string. It'll also say literal Smith. Age, however, is not a string. Age is an integer. I'm going to say that again. Age is not a string. Age is an integer. And the reason why it is an integer is because we are using numbers with no decimal point without quotations. The computer already knows that this is an integer, so it's going to assign the value or data type integer to age. Now let's take a big step back for a second. We've been talking about strings, now we're talking about integers. I'm moving kind of fast. I really want to take a big step back and I want to talk a little bit about why this is important. All right? Why are these data types important and why do we use them the way we do? The data types are important because the storage location needs to know what data type it is allowed to hold. Moreover, if I want to do some operations on this data type, I need to know what kind of data type it is. Notice that first name plus last name gives me John Smith. But what happens when I change this out for numbers? If I add string 45 to string 45, what will happen? Well, I'll get 4545 because, as I said, strings are just characters that are being printed. There's no arithmetic, there's no operations being done here. So these two values will remain the same because they're immutable. They won't change. However, if I said age 45, and I just do it right here, plus 45, what would happen? I would get 90. And the reason why is because these are numbers. Now remember, an integer is a number without decimal point. That's what an integer is. And if you ever try to cast an integer as a floating point type, which is a number that has decimals, you are going to get an error. Or what you will get is that the decimals will get truncated off of the integer and you will only get the number. It will not round. Okay, great. So we're looking at integers, and that's how integers are. The only floating point type that we find in Python is float. So if I want to create a float, all I have to do is add a decimal point. And there you go, 45.0. Okay, those are the three big data types that you need to understand in Python. But let's talk about something that I think is very important, especially moving forward. Sometimes you need to go from one data type to another. sometimes you need the data type to actually change on the way out. How would we do that? Well, I talked about casting, and that's exactly what we're going to do here. So first name is the string 45, and last name is the string 45. And if I added these two together, I would get 4545, but that's not right. That's not really what I want. So what I would do is I would attempt to convert these two data types, or cast these two data types, first name and last name, as an integer. And I would do it this way. I would use the int function to cast it as an int, and guess what? I get 90. And the reason why is because PIMDAS, order of operations. Please excuse my dear Aunt Sally. The first thing which is executed in any line of code is what is in the parentheses. So what is in the innermost parentheses is executed first. So what's here is a value of the string 45. Great. Well, what's going to happen? Now the function int is going to take that value and do something with it. Hopefully, it's going to convert it into an integer. And once it does that, then I want it to add these two integers together after they've been cast as integers, and then I want you to do something with it in the console via the print function. This is also true if I wanted to convert first name and last name to float. Now, my question is, what do you think is going to happen? If you don't know, pause it, run it, and see what happens. All right, well, if you've paused this and you've run this, you should know that you just get the decimal point, 90.0. But here's a good question. What happens if I add an integer? All right, if I add an integer to a float, what will I get? Once again, pause this and run it and see what happens. What you should get is another float. Because once you add a float to an int, the outcome is going to be a float. The same is true for all the other operations that you will run into in the event that you are trying to understand, take care of, and remediate Python programming language issues along the way. Well, that's all I have for right now. If you haven't already, like and subscribe. It really does help. And as I say in all my videos, good luck, have fun, ciao.